Have you ever wondered why huge industrial machines rely on rugged devices like PLCs, while your smart home devices run on tiny microcontrollers? Today, we're diving into the fascinating world of automation to uncover the differences and similarities between these two essential technologies. And what would happen if they swap jobs? Stay tuned. Did you know that the same fundamental concept that controls massive industrial machines also powers your smart home devices? But here's the twist. One uses a PLC and the other runs on a microcontroller. But why not just use one for everything? What happens if we swap them? Stick around as we break it all down. Let's start with the PLC, or Programmable Logic Controller, designed for industrial automation. Imagine a giant factory where thousands of machines work together, 24/7. PLCs are built to withstand harsh environments. Think extreme temperatures, dust, and vibration. They're the backbone of factories, controlling everything from assembly lines to power plants. With easy-to-use programming languages like ladder logic and function block diagrams, PLCs are all about reliability and real-time control. PLCs specialize in handling multiple sensors and actuators, operating in tough environments, and running continuously without failure. Now, contrast that with microcontrollers, the tiny brains behind your everyday gadgets like smart thermostats, toys, and even medical devices. Microcontrollers, typically programmed in C or assembly, are compact, cost-effective, and versatile. While they handle less complex tasks than PLCs, they are perfect for applications that require fast, specific control in a controlled environment. Microcontrollers excel in small, low-power applications, running specific pre-programmed tasks and cost-effective and compact designs. At their core, both PLCs and microcontrollers do the same job. They take inputs, process data, and control outputs. Whether it's switching on a motor or adjusting an LED, the logic remains the same. Common functions include both processing digital and analog inputs, executing pre-programmed logic, and being essential for automation. Now, here's where things get interesting. PLCs and microcontrollers are built for totally different worlds. Let's break it down. Environment: PLCs are used in harsh industrial environments, while microcontrollers are in controlled home electronics. Programming: PLCs use ladder logic, FBD, while microcontrollers use high-level languages like C, assembly, Python. Inputs, outputs: PLCs have multiple I/Os used for high voltage, while microcontrollers have a limited number of I/Os and of low voltage. Reliability: PLCs are on for 24/7 operation, while microcontrollers are designed for short tasks. Cost: PLCs are very expensive, while microcontrollers are cheap and mass-produced. Both PLCs and microcontrollers are used to control devices by processing inputs and generating outputs. They both serve as the brains behind automated systems. However, the key differences lie in their design and application. PLCs are built for durability and are designed to handle multiple I/O signals in noisy industrial settings. Microcontrollers excel in compact, low-power environments and are optimized for specific tasks in consumer electronics. Now, imagine if we swapped their jobs. What if we put a microcontroller in an industrial factory? It wouldn't last a day. The harsh environment would fry it, and it wouldn't handle complex automation tasks. What if we put a PLC inside a smartwatch? Overkill. A PLC is bulky, power-hungry, and way too expensive for a simple fitness tracker. Bottom line, use the right tool for the right job. So there you have it. PLCs and microcontrollers are both automation powerhouses. However, PLCs and microcontrollers each have their own strengths tailored to specific applications. PLCs provide robustness and reliability for industrial automation, while microcontrollers offer compact, efficient control for consumer devices. Both built for very different applications. Whether you're controlling an industrial robot or a smart toaster, picking the right one makes all the difference. Thank you for watching. If you found this video insightful, please hit that like button, subscribe for more tech insights, and leave a comment below on which one you'd choose for your next project. See you in the next video.